Hello and welcome. I'm Bill Wake. We're here working on evolutionary design. We've taken a basic interpreter that we wrote a couple months back, I guess at this point, and we're replacing the parser component on it. We had a recursive descent parser, and now we're putting in a parser combinator approach. Today we're going to focus on input and if, and we're working our way around on the statements. So we did let's see, def, dim, for, go sub, and go to yesterday. And we skipped if because I think it was a little hard to start, although we didn't finish input either. So there you go. All right. Let's see. Let's get over to our IDE. Make sure my volume's off. Yes. Okay. Let's see. We left off with syntax errors here. Let's see what we got. Okay. Yeah, we don't have the input. We should have the remaining input as this, and then that's still not going to be good enough because this thing doesn't like tuples, right? String int can't conform to equatable. I don't know why. I mean, it's a language thing. If I passed a string, it's equatable, a number's equatable, but a tuple of those two isn't. And that just seems off to me. It really has made my testing less pleasant. All right, but I realize we can. So the problem is when we want to compare a tuple, we have to go through a manual approach, basically. Did we do that here? Yeah. Oh, well, okay. We basically have to split apart the target and deal with it. Now, I wonder if I can. I got two ideas this morning. One is to try and make this a tuple. T1 of equatable at T2 of equatable. And protocol equatable. Apparently not. Okay, that was my first approach. My second one, we're extending parse result. Let's go look at it. So it has these two values on success, the target value we're trying to transform to, and the remaining input. On failure, we have a position and an error message. The reason that check code got so complicated is because you have to peel apart the target and array value from the success thing. My idea is I could make an extension that provides methods to get the target and the remaining and the error for that matter. But that's my idea anyway. So it's function. Well, actually, I don't even need a function. Let's see. I want to say. Well, maybe function is the easy way to do it. Function. I forget how you write this. Let's call it success target of. I guess we still got target, so maybe we're okay. Function success target yields a target, and it's going to have some work to do because it's got to do this stuff. Okay, if it's not, I'm gonna. I don't want to do XCT fail. I think I can. Maybe this thing can just be throws. It's only for testing purposes, so I'm. Oh, and I don't have a type that can do it. Let's make it. Can I do precondition message? Yeah. result, I think I can print self was not success. Okay. A little weird maybe, but I'm just trying to get something to blow apart. My assumption is my tests will only call this when they're really expecting it. Let's see. Why is linker taking so time? Can't tell you that one. Windows MSCC. I mean, if you have a lot of stuff, it takes more time. If you have a lot of dependencies, it can take more time. That's probably the big thing. Like if you have a lot of files with a lot of cross dependencies, then you get a pretty slow link. But other than that, that's kind of a generic answer. Sorry. The way you might try and figure it out is do binary slicing and try and link half the stuff together and see what happens and stuff like that. One specific product. So your linker's just slow in general. Yeah, I really wouldn't know. Yeah, sorry. Yeah. Well, I mean, every public method or it's got to keep track of all the public stuff. So if there's a lot of public stuff and it's, if your methods are kind of reaching all over the place, then everything gets kind of crisscrossed. That can make it slow down. But yeah, I don't think I can help you on that. Sorry. um, yeah, I had try Stack Overflow maybe, or uh, been a long time since I really did any serious Microsoft C. um, okay. All right. So we're trying to pull out these fields. Now we know we have a success. So we can say, oh, well, we've got them here at target and remaining. Okay. So let's just return target. And I don't really care about remaining with this. Okay. Immutable value. There we go. Huh. Yeah. No, I get you. All right, and let's do a success remaining. Input. And remaining. Okay, so these two helpers, target. Okay, this should, let's see. Where's my test that's having troubles? Okay, let's split this test up. Let's do an assert equal. Assert equal. Result dot zero. It's a pair, so dot zero is the first thing, and we'll do remaining. Sorry, result dot. Let's do result dot success target is string, and success remaining is supposed to be 2. Okay, so I think these will, whoops, cannot convert string int value of type inject. Maybe this hasn't built. So it found success target, it found success remaining, but cannot convert string int to expected argument type string. That just doesn't make sense to me. Let me try a build again. Because the type of success target should be, I don't see how it's string. Oh, this is not the parse result. Oh wait, it is. This should be a parse result. Okay. The input is ints. The result type should be string. Dot target. Should be, oh, no, what's going on? Type of this is target. Oh, that is the result. Okay. Yeah, I'm going to have to pull out the pieces. Success target. It's a tuple. So the first one's string. The second one should be a 1. A 1. Okay. Yeah, this is still awkwardish. Alrighty. So we're saying you're satisfied if you match a 1, and we're going to inject a string and then match a 1. So they're both required to be there. This returns a tuple. When we call parse, we get the tuple that is string comma 1, and this is the rest of the input. That should be okay. I have no idea at this point if we implement any of this, but okay. Build succeeded. It's testing. Okay, good. We need to make this pass. I don't think we implemented it yet. Yeah. Okay. Right. So unfortunately, it just crashes our code. But it does stop. So could be worse. All right. And we're doing parser combinator inject. Well, here we go. We returned a failure. Okay. So the inject, the target is the injected value. There's really no failure that's going to happen. We're just going to push the injected value out. Return value. I guess it's a success with value and the remaining input. We didn't touch the input. Okay, and let's see how that does. Yay. Okay, good. I still wish I could do tuples on my assertions, but there's just no obvious way anyway. Not obvious to me. Therefore, it's not obvious. All right. Success target, failure target, success remaining. Good. Okay. This thing doesn't fail, so now we want to use it. And let's see. I think if we look for inject, I think I typed it in at some point. No references. No, let's just find text. Probably commented out. There it is. Okay. Right. Yeah. So doing our input, the problem is, well, let's see. We can see it in here. The input statement looks like this. It's input, and then you're allowed to put a string and a semicolon, and then the variables you want to read. Okay. Or you don't have to have a prompt. You can just do input A, B, C. All right. So we're trying to match that up here. Here's the string. Oh. Well, we need to match the word input first. Oh, that's prompt plus variables. Okay. Sorry. The input parser itself. Yeah, this thing. Let's see what we get. Okay, so we're going to match the word input. The ampersand greater says only take the one on the right. So we're going to inject non-function type string question mark. Inject cannot call value. Let's try token dot string. Oh. Token dot. Let's go to our token class. Token. Oh. Right. Okay. I don't know where I got off to here. Okay, a token that's that. Okay, let's let equals token line. I don't know the line. I don't think it's going to matter. Column 0 won't matter. But then type is token type dot string. And then this is a var because we're going to assign string to it. Token dot string equals nothing. Okay. Inject. Let's call this empty prompt. Okay, and the labels, sure. And empty prompt. Okay. So, let's see, is that gonna wake up and be happy? We're trying here. Let's take this off for a second. Okay. It's either a prompt plus variables or it's an inject plus a comma list of variables. So I think the type should match. Optional and then tuple. This is the worst part of this thing. Check token target RAPL. Is it that it's optional? I guess it's not optional in this case. So we're trying to make it so it's either prompt plus variables, which returns a string and the comma list of variables, or we're injecting a empty prompt and a comma list of variables. All this is trying to get the error message better, and I'm not convinced that's worth the trouble, but okay. Then we got make input statement. This should be okay now. It should both branches are compatible. So let's see, in make input statement takes a token, optional token, and an expression. Okay. This value was never used. Prompt plus variables. Well, it looks like it was used right there to me. Yes, thank you. Okay, let's move this one up. Do prompt. Let's make this even better. How about default prompt? Okay, so the prompt plus variables is the string, semicolon, and that, and we're trying to catch this message coming out. All right, otherwise it's just a comma list of variables. Code after return will not be executed. Okay, so let's take this out. And we're trying to get something more like semicolon required rather than just bad character and input kind of thing. All right. I'm going to try and run this now. Oops, did I have this on? Okay. That passed. That's a good thing. Okay. It's kind of a consequence of this new style, but notice these two things. I conceptually, I would rather just say it's a optional prompt followed by a list of variables, but that didn't check the syntax the right way. It said, I didn't even see any optional stuff here. Ignore that and just look for the list of variables. And then right away it says, oh, I see a string here. There's, so it didn't realize it got the string matched. Okay. Let's uncomment. Oh, we got rid of the junk. Okay. It's a little awkward maybe, but okay. Let's pop down to this comma list of variables. See who calls that. Okay, those are both in the same one there. We got a couple places. Read and us. Okay, let's convert this one. Okay, so let comma variables parser equal. Okay, and what we're going to find is a variable. Well, actually, all this is variable parser. So if it is a variable, go to variable parser. Otherwise, at least one variable is required. We think we'll live with a changed message here. So this boils down to variable parser. Okay. And then while it's commas and it's variables, we have a special notation for that, which is this sort of exponentiation thing. And we're going to match comma. Oh, and we don't need to keep the commas around, so that does it. All right. And then we need to do the semantics. So that did the syntax checking, but we have semantics that we keep track of these variables. And they turn into a list of expressions. So I think we can just all we're returning is a list of expressions, right? Yeah. So we'll just return, I think maybe we're okay. Maybe that's enough. Okay. And so to call this, we need to do a wrap. Let's see. Let's return try wrap new comma variables parser dot parse. Okay, and then we'll comment all this stuff out. Initialization. Oops, cannot convert value. Bind token expression satisfied token. Oh, I always forget self. It's just junk the wrapper needs. Now is the type right? Yes. Oh, good. Okay, so this should just work. Okay, so much for that. What do we got? Oh, missing variable name. Oh, I'm completely happy with that. Actually, I might have a way to, well, let's make sure this passes. Does not. Okay, who's failing? Oh, missing variable name. Okay, but I may be able to force a message. Let's see. There's another combinator for that. It's percent, I think. It's like, what's the message you really want? Let's see if we get that. Oh, that's a good sign. At least one variable is required. Yes, that's the message we wanted. Okay. Should pass. Yay. Okay, and let's clean this up. Okay. All right, now I'd like to inline this, but I think I'm just going to pull this parser up to the top. Let's see, we defined some parsers early, and this is one. It's shared across a number of things. Okay. Variable, comma, variables, parser. Bind token yields array of expression, and we'll do a bind. Okay. Parser dot bind. Comma variables parser dot bind. Comma variables parser dot bind to comma variables dot parse. I think that's better. Okay. Let's see. So back where we were. Well, we got some work to do there. Anybody who wants to use comma variables parser. Let's see. I guess my callers of this wrap old comma list of variables. This should be okay. Let's make sure this is nothing. Doesn't blow up. Okay. This wrap old, well, we did a wrap new. We can just call comma variables parser. Okay, should be neutral. And same thing down here. And then the read, this is still an old style, so it's going to try wrap new self comma variables parser dot parse, and it needs, yeah. think that should work. Okay, and then comma list of variables. Nobody's calling it anymore. Good. Run them. I guess we did multiple things. I'm not doing my check-ins right here. Okay, well, so what we did was we added some helper methods to parse result testing. We moved the input statement to a new parser and moved comma list of variables to a new parser. Excuse me. All right. And so I think we get to claim some progress. Let's move this out of the way. We'll take a check mark. Move that over here. Input's done. And let's tackle the if statement. Okay. I don't know. I put it off because if is recursive in statements as well as expressions. So you can have if followed by a line number, or you can have if followed by a bunch of statements. And I think that'll be a little challenging. But I've been wrong before. Like, when's it hard? When's it easy? I don't know anymore. Okay. Expression parser requires a float. Okay. Okay, so this is the if then otherwise statements. Okay, yeah. So it's the if comes in, then you have an expression. It's got to be a float type. It could be a Boolean because Booleans turn into floats. Then we have the keyword then, and you can, if you have a token, an integer, then it's a line number. And if you, and it turns into an if go to. If you have statements, then it turns into this if form with statements. Okay. We see some semantics. You need to check for the float type, and then we have some conversion stuff to get it formatted, put in the right type to return a statement type. Okay, so this is the if parser, and it's going to be, we got to match the word if. We don't care about it, so this will take the right hand side. All right, then we need an expression. Expression parser, I think that's fine. Parser. All right, and then we want to match a then. Okay, so everything starts the same up to here. If expression then. Okay, and this whole expression the result of this is one expression coming back. Okay. Then let's see, followed by, and it's really an or situation. So let's put this here. Okay. So what can you have? Well, one case is the integer token type. Okay, so we're going to match an integer. Match an integer. Now, this may Okay, how we compute this is going to be a little interesting. The ORs have to have the same result type, and I was hoping I could make them statements, but I don't think I can. Oh, I got to get over this parser thing because I'm used to. I worked years ago as a compiler person at DEC or Digital, um, and one of the things we cared about it was making sure the parsing was fast. And now I'm putting in this parser that's willing to backtrack, and it's kind of like freaking me out a little bit. All right, let's figure out the rest of this though. Okay, if it's not a line number, then it's supposed to be a bunch of statements, and that is an old. We'll have to wrap the old parser for that. So it's a wrap old self and statements, and that's the recursion because if is a type of statement and it calls on statements. And yeah, so okay, this should complain. Yeah, I don't think that's the right complaint, but it should be complaining. Type of expression is ambiguous. The problem is the result of match of integer is a token, and the result of this is, I'm guessing, a list of statements, but it could be something else. Yeah, array of statements. These two things have to be the same type, and they're not. Okay, so I think I'm going to have to do a bit of a prefix thing again. So let if prefix equal this stuff, because this part we trust. I guess I won't need the parens. Okay, so now the two choices are we can have if prefix followed by match of integer. Sorry, this should be an ampersand. Match of integer, or we can have if prefix followed by match followed by statements. Okay, and that goes away. Now the problem is and requires the types to satisfy token target. Operator and requires keep left, keep right, satisfy bind token expression and array of tokens. Okay. Yeah, I think what it's saying. Let me parenthesize this. I think in the end I have to put my processing on the two branches because they could create two different kinds of statements. Okay. Are you still unhappy? Yeah, there's a little bit of goofiness going on. Okay. I need this. I don't know. If prefix, let's make sure this returns the type I expect. It's a little complicated to read. Okay, come on. Hey, what is this thing? Something's wrong there. All right. I believe this. There we go. It's keep left, keep right, satisfy token, bind token expression, satisfy token. So keep right of bind token expression should be expression. And the keep left of expression and whatever is expression. So this thing should be giving me an expression. And this one, match integer. I don't know. I think I'm going to put the helper function and let's see what happens from there. So this is if go-to takes an argument of type expression and token, and input remaining of type array slice of token. Okay, and it better produce a statement. Okay, and let's just return .skip for the moment. And we'll pipe this into that if go-to. And then this one, function if statements has an argument of type, well, the first one's an expression. The second one is an array of statements. And I don't know. I think there's something going wrong with that. Is that the right type? I'm feeling like I'm messing something up. If statements. Okay, and oh, hey, nice to see you, Shebang, again. All right, this. I think I've got the wrong argument. I need to do this because I'm checking things as well as transforming them. Okay, let's see if that's happier. If it's not, I'm not sure what's going on. Okay, yeah, this may be progress. Target type 2 could not be inferred. This stuff kills me. Okay. Expression token, array slice of token. That's the type of if go-to. Okay, expecting argument type, a tuple, yes. Keep left, keep right, bind token expression, that is expression. Okay. And why is token.target? Yeah. Okay. The funny thing is it often tells you, like it tells you what it's doing, but yeah, it says AKA and then it explains it to you in moderately somewhat less complicated form. Let me pull this again. Okay, let if go to parser equals, let's just take this much and make sure we understand what it's doing. Okay, so it's a tuple. Keep left of keep right of this is expression, and the keep right, keep left throws this away. So it's expression, comma, token. Yeah, that's right. That's what it should be. Okay. And let me check this thing. I don't know if I can. No. Try that one. Bum, bum, bum. We have some. Okay, let's check the type of this method. Sum should be even. Takes values of an arbitrary type. Oh, it's supposed to return a parse result. That's see, the error message just does not tell me that. Parse result of token goes to statement. And this should be the same thing. Parse result of token goes to statement. And this is success. Remaining. Skip is not the right return. Whoops, remain. Okay. Expected parens. Okay. Now it's happier. Okay. If parser was never used. All right. So we can return try wrap new self if parser dot parse should replace the rest of this. And it's totally wrong at this point because we're returning skips, but I think let's make sure it's getting that far. So all our if statement tests should complain. Yep. So if was true and parser tests, yeah, skip is not equal to an if statement. Good. All right. Now let's, sorry, lost where it was. There. Okay. Let's make these functions do their job. Well, one thing they have to do is they have to check the expression and make sure it's a float type. Now, I don't know, I get too many ideas and I start juggling them, but we do this elsewhere. So let's find where we do this. Require float type. We do it with this big old try catch, and I really dislike that, but I don't have a perfect solution either. Require float type. Okay. Okay, yeah, that's kind of a mess. All right, we can use it, but it's a mess. I'm focused on getting the parsers done, and then I want to do a big sweep of cleanup, I guess. Let me add that to the to-dos. We're going to move this forward to new if parser. That's what we're working on. Okay, but dimension and force sizes make require float types be better attached to expression and type. Okay, so I should be able to say expression dot is float and get a good answer and then use that instead. Excuse me. Okay, and let's go back. So let's get the if go to part first. Okay, so we need to return an if go to with an expression and a line number of the float. Okay. Let's peel these apart. So expr and token equals the argument. We want to return an if go to expression and token dot float bang. All right, that's what we did down here. Well, line number token dot float. Okay, that'd be better. It's not if go to. Oh, success. That with remaining. Okay, so we had 9 failing. Some of these should start passing, at least 1 or 2. We're still not enforcing the type, so there's at least 1 error left. Okay, yeah, a couple tests passed. All right, let's do the same kind of thing down here for this one. If expression and statements. Okay, expression and statements. Okay, success with dot if of expression and statements. We need to pull those out. Expert statements equal argument. I don't think I can do it the other way around. I think if I do this, yeah, it doesn't like it. Okay. Return if expert statements remaining. Again, a couple tests should pass, maybe 1. Okay, and the ones that aren't, what's their problem? Check numeric type and missing then. Oh, but we can fix. Okay. The missing then, we can put a message on here. Okay. If the if's wrong, it's not even going to go down this statement, so it's not an issue. Okay, and let's see if we got 1 test failing yet. Good. Okay, and that's the numeric type one. We tried to do an if on an $a, and that doesn't work. Okay, so the bad thing is both of these, they both have to check the type of expression. I hate the duplication, but I don't think I have a way around it because I can't. Oh, maybe I do. If the expression, let's see. Let's find require float type. Float types. Okay, that's a little different. Oh, that's my old check type. Okay, my idea is, let's go back. Okay, this thing, I think we might be able to do this operator, require float type. Okay. And that thing is float type. It takes an argument of this time its expression, because that's what our parser produces here, And it also takes remaining. Of type array slice. Produces a parse result, so it can throw an error if it needs to. Token and expression. Okay. I guess this is an expression, so I don't have to peel it apart. Okay. And let's find this. Require float type. I guess that's this. Why is that a try? I don't know what the tokens have to do with it. Okay, that's my message. If expert out type not equal number. Yeah, let's take this. Okay, this is, yeah, okay. I want to do more, but I think we can. I'll just paste this for reference here for a second. Okay. Okay. If expression type is number, then we have a success. So let's return a success, return the expression, and remaining. Yes. Okay. If it's not, we have an error. Okay, so we're going to return a failure. And it needs a position. We're going to take remaining dot start index. And it needs a message, which is this numeric type thing. It's required. Okay. Nil. Okay. That, I think, will give us an expression that's guaranteed. It gives us an expression that's guaranteed to be numeric. Okay, and so our thing here doesn't have to worry about it. That is progress. Okay. So this should pass. Everything should pass. It might be, the message might be in slightly the wrong position. I'm okay with that. Yeah, all right. Clean this up. Okay. Well, so doing this prefix thing is a little awkward because we're doing backtracking to figure out which one it is. I think, wow, I can't even say which one's more common. I don't know. All right, but let's check this in. Okay, handle if with new parser. And then I notice we're doing statements still old school. All right. Well, my clock says it's time for a break. So tell you what, let's take a break, and then we'll come back and make the statements a new style parser. And this is where we're getting to this recursion, right? Because if statement called statements, and statement calls if statement. So we've got mutual recursion going on. And I think we're positioned because we can wrap old and new. I think we're okay, but we'll tackle it when we get back. So about 3 minutes, and see you then. Hi, welcome back. All right. So statements, they match a single statement, and then they look for colons, and basically it's while you find colons, then you're doing statement, colon, statement, colon, statement. And the funny thing here, this thing checking for colon and then checking it again down here, I'm not quite sure why it does that. It may mean there's some error messages that'll be affected, because well, I don't think it's going to matter. Let's do it and see what happens. Statements parser equals, well, this one's pretty easy. Statement is an old school parser, so we have to do a wrap old and self and statement. Okay, and then it's separated by, we don't care about them, but they're there, match colon. Okay, and I think that should return an array of statements. We're not doing any semantic checking. We're just matching syntax and accumulating a result. So I think we are okay. Let's look at the parser type. Keep left, satisfy input statement. Separated by keep left. I think that should be okay. So let's do return try statements parser. Sorry, that's wrap new self statements parser dot parse. And this stuff can be commented. I think this is okay. That's almost too simple if it works. Yeah, okay. Let's find our callers. Okay, so who calls statements? I think I did a search on that. Well, it's certainly here, wrap old. That one we should be able to inline. Okay, so instead of wrap old self statements, I want that, and we'll put that down there. Okay, so prefix, then wrap old statements separated by colons. This is like exponentiation. It has a little higher precedence, so that should just work. Okay, and then let's go back to statements. The other place that calls it is the top level line. Okay, so try statements. We're going to do a wrap again. Let's basically an inline. Okay, we'll take those two and go back there. Okay. Let's just paste that. I'm kind of inlining the call to statements is this part. I can even put that on one line. Okay. Wrap old self statement, wrap new. So wrap old self statement. Where'd statement go? I don't think it's far, but a statement. Okay, so that's the original routine. Okay. Did I change places? I did. Okay, let's find that again. Okay, so wrap old statement colon, statement parse. That type should be array of statement. Well, parse of that. It's not complaining, so it's returning the proper parse. Okay. Okay, everything should work. And let's find statement now. Nobody's using this. Okay. Okay, let's take this. I think, whoops, nope. Okay, let's see. Well, let maybe a mess, I don't know. It's the assignment statement, and it's kind of, well, it's got all the most of the complexities in the expression, so maybe it won't be too bad. Okay. Let's find the let. Now it's odd. This is out of position to me. Excuse me. One of. Okay, I'm gonna pull. Oh, that is together. Okay. Okay. I almost want to move these into here, but I'll leave them for now. Okay, so statement. Let's see, what's this one? One word statement. Data parser. Okay. See, we're trying to get all these together. Once we have them all producing a statement, then we can do a big OR parser and move this thing to the new parser. So let's jump to this one. Let assign. Okay. Wow, this might not be too bad. I don't know. The error messages give me pause. If case variable return try assign. Oh, assigns did all the work. Okay. Let's do assign first. I don't know if I pulled that separate variable. Yeah, that's really assign. Okay. So let's start there. Okay. We're looking for a variable. Okay, so let assign parser equals. Well, we should see a variable parser. And since we're wrapping new, it is new. That's the thing we want. Then we need a equals. So we'll keep this match dot equals with this message. Okay. Assignment is missing equals. Yeah, okay. Wrap new expression parser. Let's make clear this is that. Expression parser. Okay. Then we need to do a require matching types. Which is a little different. Okay, let's do like we've done before. Let's focus. Let's ignore the error message for a moment and see what we have. So we have variable. We ignore the equals. We require it, but ignore it. So we have a variable which is producing an expression. Make sure that's true. Yeah. And an expression parser which produces an expression. So we have a tuple of expressions. So this thing is variable exper in, well, I don't even know if I need to do that. That's pretty clear, I think. It's a tuple, so the result is statement.assign $0.0, $0.1. Okay. Variable and expression. And then let's comment this. And we'll return it. Try wrap new self assign parser dot parse. Okay. So what I expect is some tests will fail because we're not doing this require matching types, but some should pass. So normal assignments should be fine, but ones with errors should be problems. Okay. Number equals string. Yeah, that's illegal. No error found. String equals or number equals string type mismatch. Yep. So both those have that problem. Okay. Let's go back. And I want to say we can do this. I'm going to do this thing, require matching types. And I'm going to define a new one. It'll use the old one, but, or maybe it will. It'll use the ideas anyway. Require matching types. Okay. And the argument is expression. And then we have the remaining is an array slice. So this is the input of token. Okay. That whole thing produces a parse result of token goes to expression. Okay. Now let's find these other methods. Require matching types. Okay. Well, that's pretty simple. We don't like we're handling our errors differently, so the parse throwing this is not convenient. But whoops. Assign require matching types. Yes. Okay. So let left, right equal argument. Okay, if the types are different, we're going to return a failure. The position, well, we're going to use remaining again. This may change the error pointer a little bit, but that's okay. And where did that thing go? Require matching types, type mismatch. Oh, there's another one, type mismatch. Okay. Type mismatch. And otherwise, let's do this properly. Okay. Otherwise, we return success with, well, we're just going to pass argument and remaining on. Okay, so that should be fine. Okay. And this should all work. Good. So, I mean, I'm pretty happy when I can do that. It's, you know, it's a moderate replacement, and it just works. That's a good sign. But we can certainly check in, and we can release. We've got a half old parser, half new, but that's okay. All right. So I guess assign. Let's see who calls this. Find symbol. Okay, there are a few places. That's the let statement, and this is the direct assignment. Okay. That sort of says I should move this up again. Assign parser. Okay, let's get up here. Token expression. No, he produces a statement. Okay. Okay. Okay, so assign parser is now set, so I don't need it here. That should be okay. And anybody who called it, instead of assign, they should just call assign parser. Is that right? Let's see if that one works. Okay. We don't need the name because we look it up inside the thing. And then the last one was over here. And then this is dead code. Okay, I'm always behind on this. Okay, if new assign parser. Okay, and then we want to do a let. Okay, so that one's done. That one is not. Alrighty, let parser. Let's close out some stuff. Case let assign. Okay, so this one is match let. So let parser equal match let. If the variable, if it's a token type, I don't know who's going to do this, but maybe we can well, ignore that and keep this, and it's we want to call assign parser to do the real work. And if assign parser fails, then we want this message. Okay, and this whole thing, assign parser, well, assign parser returns a statement. This is an error message. If it fails, this gets ignored, so it returns a statement. So we can return try let parser, sorry, wrap new self let parser, whoops, let parser dot parse. Okay, comment these. Okay. And then who calls this? Well, we think we know we're going to have that in one place. Find let assign. Yep. And we inlined that. I really should be checking those in first. Okay. All right, what's next? Next is next. Cool. Is that right here? If then. My alphabetical skills have apparently atrophied somewhere along the way. I think it was at the bottom. For statement, do for, do next. Okay, next statement is just next in a variable. So let next parser equals match next We don't care about the next itself. And we want a variable. Well, that's require variable. Okay. That's a match token with variable required. And then we return the string of it. Well, let's wrap it and be done. This is an old require variable. Okay. Cannot convert string. No parentheses. Okay. And then all we have is the variable name, so we can produce statement.next with $0, the variable name. Whoops, gotta call it. Return, try, wrap, new, self, and next parser. Parse. Okay. Let's see who calls require variable. Parser tests. Interesting. Huh. Okay. Okay, this is just the method we decided to test with. Okay, I'll leave it around for a little bit, but let's inline what it does, because I think what it does really it just does a match. And then it pulls out the string. I think we can accommodate that. So it's match dot variable with variables required. Okay. So this is match dot variable with variable is required. Okay. Now that's returning a token instead of a string. And we can get the string from, I don't know if we need an exclamation. Okay, so variables required, we're no longer calling the method. Okay, I'm going to leave it there because the wrapper test uses it, and when we get rid of the wrappers, we can get rid of that. All right, wrap new self, next parser. I think, again, we can inline this. Oh, let's check in. I keep saying I'm going to. All right. Move next to new parser. We'll delete that. Should be complaining somewhere. Do next. We don't need the statement. Next parser, instead of return, try wrap new. We're just going to do the wrap new directly. Inline next. Do next. Okay. I guess I want to know who else needs that require variable. Okay, let's do my unusual a comment for delete me. Usually I just delete it. Delete me when the wrappers go away. Maybe I'll say a to do. All right, that was next. I guess I can put that up here, be a little closer. The on statement. Well, we're knocking through them. Okay. On. I don't know if there's a do on. Nope. On. On. Okay. All right. So this is on go to or on go sub. Okay. So what you do is you say on expression and then you say either go to or go sub. And then you give it a list of line numbers. So this is okay. This should be interesting. It requires a line number. I don't know. We'll see. Okay. Let on parser equal. We're going to match the on. As usual, we ignore the keyword and keep the rest. Okay. We need an expression. Expression parser. And then we need go to or go sub. Okay. And okay, let's keep the expression. Okay, followed by, I think I have a match that will do that. Let's see. Match. There we go. Token type, one of. Okay. One of a list of tokens is dot go to or go sub. Okay, and I need to keep it because I need to know which one I matched. All right, I think I can put that in one line. Okay, go to go sub, and then I need a bunch of integers. Okay. So this is, well, it's also and. I don't know, this, try to make this readable. And I think it's integers separated by commas. Yep. And they get a list of targets. Okay. And match dot integer separated by comma. Can one of take a message? That'd be nice. Okay. Let's not worry about the message just yet. Okay, so match integers separated by commas. That looks like it does all the syntax we got. Then we got to do some decoding and whatnot. All right, so I'm going to skip the error messages. I'm going to feed this to well, are there errors that can happen? I don't see any. I'm not enforcing any rules, so I guess I can use my simpler pipe to. And this is let's see, make on statement. I think we'll just separate that out. It's a little complicated. Okay, so make on statement. You give it an argument. The type is, well, it's got to have an expression. Then it's got to have a token, go to or go sub. That whole thing is followed by a list of token. Yep. And it returns a statement. Okay, so let's peel it apart. Expert token and what's that last one is the targets equals argument. Can I do this in one big thing? Expert type that equals argument, and we'll return a skip. Okay, and we call it return try wrap new self on parser parse. Excuse me. All right, and comment that. Okay, so this okay, we match the on and the expression, then we match a go to or go sub, then we match a comma separated list of integers, and we make a statement out of it. And oh boy, I get to do multiple. That's good. Okay, I need to be more aware of that one. This should be pass. It may pass something. No, it's not going to pass anything because we're returning skip instead of on. Okay, but we'll see which tests are related to on anyway. There should be a number. Okay. One go to. Right, that's runtime. These are parser. Skip is not equal to something. Okay, good. Okay, so let's what do we have to find? We have to find the expression and the targets. Okay, the expression is itself. Okay, the targets, let's call this target tokens. The targets are target tokens dot map. I think I can just say the name of the thing, right? And this is float. Just going float. And map that to line number. Well, apparently that doesn't work. Okay. So map that to line number of token dot float. Okay. And let's return on goto the expression and the targets. Whoops. Targets. I think this can fit on one line reasonably. Okay, on goto expert and targets. So I expect that anybody who did a go sub is going to complain, and I expect some error messages to be wrong. Okay. On go sub, it treated it like a go to, so it didn't do the go subbing. On go sub, a go to is not equal go sub, and then some error messages. Yep. All right. Let's see. So the last thing we have is type is dot go to. I think that's all we do, right? Oh, it's token. If type token is go to, then return on go to. Else on go sub expert targets. Okay. Now that should fix one of those, maybe two of those. No. Okay. Failure return called before go sub. Did I do that backwards? If it's go to, do on go to, else do on go to. Not even backwards. Okay, let's try again. I think those on go sub tests, one's the runtime, one's the parse time, those should pass, yeah. Okay, now these did not find expected value, missing expected character, extra characters in the line. Yeah, I think we can try and get the parser to put those in. On statement requires go to or go sub. All right. That's the match, the one of. Let's see if that thing can take an argument. Satisfy. We could take a message. Let's find the other colors. Okay, this one, I don't think we care what the message is. If they don't do it, we don't worry about it. So that one's okay. This is us. This is one of the relational operators. Again, I don't think we care about the message. So let me make a variant. Okay. Where did I see? Okay, satisfy message. Yep. Well, no, I think I can default it. Let's do that. If they don't use the message, then it shouldn't matter. Tokens and a message equals expected value. I don't want to say token. Symbol not found. Okay. That should pass. Oops. Oh, I do have to put the type. Okay. Thought you could infer it. Okay. Same errors. Yeah. Okay. And let's go find our one of these, but now we want a message that is on state requires go to or go sub. Okay. I think that'll fix one. Yep. Okay. On requires at least one line number. That may. On statement requires. I'm gonna let this one go, I think. But this one we can. Let's see. If it doesn't match this. Okay, so this. We're saying if you don't match this properly, I'm going to change the message. I'm going to say on statement, percent requires comma separated list of line numbers. Maybe statement is redundant in this. No, I think it reads better. Okay. I think one or both of these will produce that message instead. On statement requires comma separated list of variable. Okay. This one, extra characters and a line. That's probably an acceptable change to me. I mean, the last thing of the line is the comma. I will accept it. So I mentioned before, I'm willing to make exceptions on error messages if they don't point to exactly the same location or they change the message slightly. I'm willing to do some non-refactorings, make these variants okay, or variances. All right, that's much more concise. Okay, that should be good. Okay. Then we'll do the inlining. Goes here. This is okay. Build failed. Okay, that's a refactor. Next. Print, and then on is done. Okay. Print statement. Okay, he's got some stuff going. All right. Well, let's take a quick break, just two or 3 minutes. One statistics student, welcome. Hey, I'll be back in a couple minutes. I just have to get a drink. And do I know anything about Python? Just the barest bit. Sorry. I've dabbled with it, used it some, but I've got friends that are very into it. I let them go for it. So sorry, can't help you. Okay. 2 minute break. Welcome back. All right. Let's tackle this print statement. Okay. So the thing with print is this printables. Let's go look at that type. So you have expressions, but you also can have thin spaces are represented by semicolons, tabs represented by commas, and new lines by end of line. So our print statement handles these four kind of things. But we produce a list of, it's not just expressions, it's printables because it's got these extra types. Okay. Let's see. Oh, this is interesting. All right. Okay. So, as usual, we'll make a print parser equals, and we got a match print, and we don't need the keyword once we're there. Now this, okay, so basically you can have, well, really you're looking for semicolons, commas, or expressions. This is sort of a cheap way to know that you haven't gotten to the end. But if you see a colon, then I don't see the issue. Okay. And notice these are not they're not separators. That's why it's a little touch weird. So it's either a token. Okay. So yeah, what's going to go on here? Well, we're going to have three things. We can either match a colon, no, a semicolon. Okay. But we need to turn it into a printable. Okay, so it's a touch weird. Oh, let's see, this goes over here. You match a semicolon, and then we're going to convert that to a thin space. I don't know if it'll infer that type. Yeah. Oh, well, we need that. And this is printable. Okay. So if you match that, or you can match a comma, in which case you should convert it to a tab, or you can match expression which needs to be converted to printable. Oops, no, I need the expression now. That's printable.expr of $0. Okay, so each of these turns into a printable. That's good. Semicolon, comma, or expression. So now we have an array of printables. And the rest, okay, that's all kind of semantics. So let's pipe the whole thing. I think I need more parentheses. Okay, so these three alternatives, they form one block. Okay, so we match the print, and then we take one of these, and now we have, sorry, this is 0 or more of these. Okay, because this while loop doesn't require 1 to start with. It's just 0 is acceptable. Okay, we'll insert a new line if that's the case. Okay, and this whole thing then can pipe to make statement. Sorry, make print statement. And we'll do a try return, return try, wrap new self print parser dot parse. Okay. And make print statement is just a transformer. So we'll do func make print statement. It takes an array of printables. Arguments is array of printable. And it produces a statement. Okay, and we'll ignore all that for a moment, and let's just at least return something. Statement not print arguments. Is values better? Okay. All right, we can leave off the return if there's only one statement. All right, this should pass some. Well, let's return statement.skip for now, just so we know how many we're up against. So this should tell us how many statements use print, and it's gonna be a gob because lots of tests use it. Yeah. Okay, let's be a little more correct. Let's do this much at least. I think this is the bulk of the cases. Okay, it's a lot more than 11. Okay, still a lot failing. Okay, let's go finish. Okay, we need the rest of the semantics. So this stuff did all the conversions to a bunch of printables, but now we need these things. Okay. So let's, well, maybe arguments was better here because I need to muck with it. Okay. Uh, let's let values equal arguments. Okay. And then if values.count is 0, turn statement print new line. That's accurate. Okay. Right. Yeah, I think this is actually pretty much the semantics. Oops. Okay, if there's no statements, right? Var. Okay, if there are no statements, no values, we just return a new line. Um, if the last one is not a thin space or tab, then we put a new line in by default. And then either way, we return the values. So it gives you an implicit new line if you don't end it with a thin space or a tab. Okay. And I think this should be good. There may be some error message or something like that, but the bulk of them should pass. So what do I know? Okay, we've changed something. That's interesting. All right, let's focus on parser tests first. Okay, extra characters and a line. I'm good with that. Okay. It's probably extra characters and a line. Predefined function missing left parenthesis. Mismatch. That one confuses me. Okay. Yeah, that's unfortunate. Okay, maybe you have issues with those. Extra characters at end of line is not equal to missing paren. Extra characters, well, that I can accept. It doesn't look like a start of an expression, so yeah, that one I think is okay. Is not. Well, I don't look for expected start of expression anymore. This may be one of those differences I can't control. Because we say parse, look for an expression, and it says, I just saw a bunch of junk. And you gotta admit, it's kind of a bunch of junk. I might might be able to get it in there though. Okay, I think we can probably put that in. Oh, 10 failing. Should be 1 or 2 less. Maybe 1 reversion. 9 failing. Okay. Print is error. Oh, now we're back to extra. Missing left parend. That's in our predefined. We got to look at that separately. Predefined. Def type mismatch. That one I don't understand. Because syntactically, function of string should look like a pretty valid thing. Okay. This executes end of line. Missing right paren. Maybe we can catch that. That extra characters expected start of expression. Extra characters at end of line. Yeah, that's kind of still true. I think that one's correct. Knock off a couple. Okay. Missing parentheses. So this is an interaction in the error handling. I'm guessing we compute that missing right parenthesis message at some point because we've been passing this test. So it's got to be an interaction between the print and the missing right parend. And I think maybe print calls expression and expression fails. I would have thought that it would have gotten further with the failure than it did with the print, because it all comes down to where it detects the error, and I thought the expression would detect it at the end, and the print would say I didn't see an expression, so there's a problem here. And then this further along message should win out. Let's look at our expressions. Maybe we can do something. I don't know. It does seem problematic. Match right parend fails. Well, let's put that message here. Missing right parend. Okay. Oh, wait. I think that's already defaulted in. Match token type message. Match token type should be missing right parend. Okay. Undo that. So it's failing this parser. Expression parser. That's the predefined. Okay, what else do we have? Predefined function, missing left parenthesis. So that's kind of in the same, here it is. Match left paren. And the message, missing left paren. Just don't know. I mean, these are all true statements in a way, but I would have liked the expression error. Why is that not? Okay, so I think when it comes through, it does the parse, it matches this, and then it calls the type check and comes back with a type mismatch somewhere. Let's see if we can figure out where that type mismatch gets triggered. Whoops. I want the Let's find symbol on that. Okay. Relational parser, require matching types. No, somebody else has to be. Okay. Require float type. The test was predefined function. Predefined function call, okay. Match predefined, match left paren, expression parser, match comma, right paren, check predefined call. Okay, this is the kind of mess I don't want. See, this thing, it has a token, so it reports the error on the function. And I think that's I may accept these errors for now and then come back in later. Okay. Yeah, this one I strongly prefer. Now that one got it. Oh, it's not a print statement. So it's definitely that interaction. And I think I may find, I wouldn't be terribly surprised if I've messed up something in the errors, that the positions on the tokens, because that's the thing that controls which error gets reported. So I think it's computing the error type mismatch, but it thinks it's further left in the line than it really is. And I think we can work from that. Okay. Okay, so let me put a to-do in on that. Okay. Oh, we did let. We did on. We did next. And we're working on print. Okay. Next on let. Okay. Test should pass with those inferior messages. Okay. Whoops. Okay, so new style parser for print. Note that several error messages have changed. Okay. Got a new print parser. Let's see where we are. Okay, let's take this. right. Read. Don't think it's hard. I just don't know. Do read. Read prints. Okay. We'll try it in a minute here. Let read parser equals match dot read, but keep comma variables parser. Okay. And read variables. Okay. Let's put this on a new line. We need to make a statement dot read $0. All right, and then so we're going to do is result equals try ref new self read parser dot parse. That should be the replacement, and that should just work. Okay. Much easier than print. Okay. All right, and then return. I don't know how hard that is. Not at all. Okay. Return is, well, it's match return. Wait a minute. I think we've done that one already. Didn't we have a single statement? Oh. Let's try adding return here. No, I guess not. Well, tell you what. It wasn't a 1 minute change, so we're not gonna worry about it. Did we check in read? New read parser. Okay. Well, we made our way quite a ways around here. We've got to do the return yet, and then once that's done, the overall parsers. There's still some old style parsers around. We're going to work on those, but we've made a fair bit of progress here today. So I think we'll pick up tomorrow, same time, which is 10 a.m. Eastern time to 12:30 p.m. or 3 to 5:30 p.m. UTC. Thanks for joining. Hope you have a good evening, and hope I catch you again sometime. Take care. Bye-bye.